All right, so this unit is all about polynomials. We're going to be, like I said today, classifying, then we're going to be combining like terms and all that stuff, and then doing solving for our higher order polynomials, long division, synthetic division, all that good stuff. Again, none of it is anything new. It is all stuff that you should have done before. However, we're going to start today by classifying them by their names. That is in how many terms they have. So a monomial is a constant, one term, okay? It can be a number, it can be a variable, and it can be a product of any numbers or variables. So some examples, 10, that's just a single number, that is a constant term, that's a monomial. You could do x, you could do 5xy, you could do x squared y. We talked about the last unit that each term is separated by plus or minus signs. Similar terms are terms that have exactly the same variables and exactly the same exponents. They just have different coefficients. Those are the numbers in front of them. So they've given a couple of examples there, 2mn squared and a negative nn squared. Those are like terms because exactly the same variables and exactly the same exponents. And then the second example there, it says negative 5x to the third y and 3yx to the third. Even though the x's and the y's are in a different order, they have the same exponents attached to them, and the order of multiplication doesn't matter. So those are also still like terms, even though they look a little bit different. And then your coefficient is just the number that is in front of your monomial, the value, the numerical value is what I'm trying to say, sorry. So if I have 5x, the coefficient is 5. So when I talk about coefficient, I'm talking about the number in front of it. If it doesn't have a number written, what is the coefficient? It's a 1. Okay, sometimes it has a negative, that would be a negative 1. But the numbers in front of your monomials are called your coefficients. And those are the only things that change when we combine, adding or subtracting our like terms. And again, if you know these words, you don't have to write them down. Okay, if you don't know them, then you're going to want to write them down because we're going to be talking about them. Again, classifying these things by how many terms they have and also their degrees. And if you don't want to write the examples, don't write them. This is just extra stuff that if you need it, it's there. All right, here are the next few. So we had a monomial on the previous page, that's one term. Then you've got your binomial, that's two unlike terms. So they would be two things that don't have the same variables and the same exponents, and they're separated by either a plus or minus sign. A couple of examples up there is 4x plus 3, 8ab minus 9a, 3x squared plus yz squared. Again, different terms separated by either a plus or minus sign. Then you have your three terms, that's the trinomial. Okay, we're used to those. We deal with those a lot with our factoring. And then anything past three terms, we just call a polynomial. It doesn't have a name. You've got a specific name for one term, a specific name for two, a specific name for three, but anything after that is just a polynomial. 4 or more terms, we just call a polynomial. And then some of the things that we're going to talk about is our degree. Okay, so I'm going to give you a minute. So when we talk about the degree of a variable, it's just the exponent on that variable. So if we have, for example, if we have the term 3x squared y, then the degree of the x is 2 because that's the exponent on the 2. And the degree of the y is 1 because that's the exponent on the y. So if I ask for the degree of just one specific variable, it's the exponent on it. Now when you're talking about the degree of a monomial, what you do is you add all of the degrees on all of the variables. So if they have two variables, you take the exponents on both of those and you add them together. If they have 3, you take the exponents on all 3 and add those together. It is not including the coefficient. If the coefficient has an exponent on it, we don't include it. We only include the exponent on the variables. Okay. So if we have the monomial 5ab squared, then I take the degree of the a, which is a 1, and I take the degree of the b, which is a 2, and I add those together, so it has a degree of 3. And then the second example that we have up there is 3 to the third, x to the fifth, yz squared. Again, we do not include the exponent on the coefficient. We only include the exponent on the variables. So we have a 5 on our x, we have a 1 on our y, and we have a 2 on our z. So we add the 5, the 1, and the 2. So that gives me a degree of 8. It does not include, again, the exponent on the coefficient. That 3 to the third, that exponent is not included. And then when we're trying to find the degree of a polynomial, which is how we're going to classify them, it is the greatest degree of the individual terms. You don't take all of them for each term in a polynomial and add them together. You figure out which one is the highest degree, which term has the highest degree, and that is the degree of the polynomial. So if we have this big, long polynomial here, if I can highlight it. Okay, let's start with the first term. If I were to find the degree of this first term, that 4a to the fourth b, c, what would that degree be? 4 plus 2 would give me 6, right? And then if I do the second one, the 5a to the third, c to the fifth, that one has a degree of 8, okay? And if I do the degree of the third term, 6b to the third, c, what's that degree? 4. And then this last term here, it has 5, 6, 4, so that would be 10. So which one of those is the highest? The last one. So the degree of that polynomial is going to be 10 because it's the highest degree of each individual term. We don't take and add the 6, the 8, the 4, and the 10 together. We just take the highest one. Does that make a little bit of sense? If I'm not mistaken, there's going to be a chart next. You don't have to write the entire chart down. I'm going to circle the important parts of it. It has examples in it as well as the pieces that we want. But we're going to talk about classifying by degree now. If we classify by the number of terms, it's either monomial, binomial, trinomial, or polynomial. But classifying by the degree, we have the first 5 degrees that we classify. Everything else, we don't really have a specific name for it. Okay. So here is the important part. If your degrees, that you need to know the degrees, we're using it by the degree here, and then also by the number of terms. And then you've just got your examples there in the middle. Now, if I have a degree of 0, that means I don't have any variables whatsoever. Okay, and that's called a constant term. That's just a value, a numerical value, a constant term, no exponents. It has a degree of 0. Okay, and if it's just one term, then we call it a monomial, which we've already, you talked about the last 2 columns there. We already wrote that stuff down. The first 2 columns is the important part here. It's how I'm going to ask you to classify them. On your quiz, I'll give you an example and I'll say classify it by the number of terms, okay, monomial, binomial, trinomial, polynomial, and then also classify it by its degree. A degree of 0 would be a constant. If your degree is 1, that means you only have one variable and its exponent is 1. That is called linear. If your degree of your highest term is 2, and x squared, or whatever the variable is, squared, that's a quadratic. If your degree is 3, it is a cubic. Again, the examples are not necessarily something you have to write down unless you want to. If it is a degree of 4, it is a quartic. You can kind of remember that by quarters. How many quarters are in a dollar? 4. Maybe helps a little bit. And then a degree of 5 is a quintic, is how we say that, quintic. Those are going to be the only ones that we actually stick a name to, degrees of 0 through 5. Anything after that, we won't have a name for it. And you'll notice on that 4th term there, on that last example, they say polynomial of 4 terms. You don't have to say all that. You could just say polynomial. Okay, so again, a degree of 0 is a constant. A degree of 1 is linear. A degree of 2 is a quadratic. A degree of 3 is a cubic. A degree of 4 is a quartic. And a degree of 5 is a quintic. Now, what we're going to do next is I'm going to give you some examples. It's going to be multiple terms. I'm going to first ask you to write it in standard form. Standard form starts with the highest degree, combining all of your like terms, and writing your degrees in descending order. So if your highest degree is a 5, then you would write that 5th power first, and then the 4th, and then the 3rd, and the 2nd, and the 1st, and the constant terms, okay? So that's what I mean by standard form. Highest degree first in descending order. That's with your degrees decreasing. And if there are any like terms to combine, you will do that. Everybody ready? Okay. So again, it says write each polynomial in standard form, starting with your highest degree. If you have any terms to combine, combine them. Descending order, and then I want you to classify it by its degree: constant, linear, quadratic, cubic, quartic, quintic. And then also by its number of terms: monomial, binomial, trinomial, or just a polynomial. So if you will take a minute and try. With that first example, I've got a 3x plus a 9x squared plus a 5x. First question, do I have any like terms? Anything, same variable, same exponents? No, okay. So what's my highest term? Which term has the highest degree, the 3x, the 9x squared, or the 5? 9x squared. So that's going to come first when we write it in standard form. It is a positive 9x squared, so I'll leave it as a positive 9x. And then I need descending order. So if my highest degree is a 2, then the next degree would be a 1. Which one has a degree of 1? The 3x. Is that a positive 3x or negative? Positive, so we put plus 3x. And then the last would be the term that doesn't have a degree, which would be the plus 5. Okay, so that would be standard form, 9x squared plus 3x plus 5. If I'm classifying by degree, what would it be called? If it's a squared? Quadratic. And then if I classify it by its number of terms: monomial, binomial, trinomial, or polynomial? Trinomial, 3 terms. So that's what I'm looking for here. If I can spell. Try that one more time. Does that make a little bit of sense? Alrighty. Second one, I got a lot of stuff going on. I got a 4x minus 6x squared plus x to the 4th plus a 10x squared minus 12. So I want to start with my highest degree first. What's the highest degree? The x to the 4th. Do I have multiple x to the 4th or just that one? Just that one, so that's going to go first. Then I would need an x to the 3rd. Do I have an x to the 3rd? Nope. So then I go to x squared. I have a couple of those, so I need to combine them. If I combine a negative 6x squared and a positive 10x squared, what do I get? Positive 4x squared. Okay. Then I need any x's to the 1st power, which I have 1. It is a 4x. It is positive. And then I need my constant terms. There is only one of those as well. And so in standard form, this thing would be x to the 4th plus 4x squared plus 4x minus 12. Classify it by its degree first. A degree of 4 would be a, look at your list, Degree of 4 is quartic. Remember 4 quarters? Quartic, kind of how I remember it. And then how many terms do I have? 4. So if it's 4 terms, what do we call it? Monomial, binomial, trinomial, or polynomial? Polynomial. Now, just a little hint. Your degree of 2 and your degree of 3 are right up there on your posters. If you forget, see how it says y equals x squared? It says quadratic above it. So y equals x to the third. It says cubic above it. Those are the names of those. I don't have the quartic and I don't have the quintic. And I do also have the linear, actually. Y equals x to the first power. That's linear. So I've got 3 of them are right up there on your on the cabinets for you. All right, number 3. What's my highest degree? 4, and I have 2 of those. I have a negative 1x to the 4th and a positive 5x to the 4th, which would give me a positive 4x to the 4th. And the only other term I have is an x to the 3rd. There's nothing to combine it with, so I'm going to bring it down. Now, again, my degree is 4, so we call that a quartic. And this time, how many terms do I have? 2, so that's called a binomial. Everybody okay with these? They're not really hard, right? All right, what would come first on number 4? Negative 4x to the 5th. Okay, then what? Plus 2x squared. And then the only other terms I have are a 3 and a 10. Those are my constant terms, which can combine. What is 3 plus 10? 13. Classify this one by its degree, quintic. And then by the number of terms, trinomial.